In this lesson, we're going to discuss loans and amortization. The process of repaying a loan, usually in equal payments, is called amortization. So if there is a debt of A dollars and it has an interest rate of I% per period and it's amortized by N equal periodic payments, the size of the payment is calculated using the formula you see. So a bank is purchasing an ordinary annuity from a borrower that pays a fixed payment at the end of each period. That's what it means to have a loan that's amortized. A debt of $1,000 with interest at 16% compounded quarterly is to be amortized by 20 quarterly payments over the next 5 years. What will the size of the payments be? So, A sub n is the amount of debt that we have. So it's a $1,000 debt. N, remember, is the number of payments that are going to occur. So there's 20 payments, 5 years, 4 times a year we're paying. So that's where the 20 comes from. Our interest rate per period is 16% divided by 4 since we're compounding 4 times a year. Plugging all of that into our formula, we have R is equal to 1,000 times 0.04 divided by 1 minus 1.04 to the negative 20. Entering that in the calculator, we get $73.58. A man buys a house for $200,000. He makes a $50,000 down payment and agrees to amortize the rest of the debt with quarterly payments over the next 10 years. If the interest on the debt is 12% compounded quarterly, we're going to find the size of the quarterly payments, find the total amount of the payments, and find the amount of interest that was paid. So again, the amount of our debt is $150,000 since he made a $50,000 down payment, so that takes it off of the price of the loan. He's making quarterly payments for 10 years, so that's 40 total payments. The interest rate is 12%, and it's being compounded quarterly, so that's 0.03 for each period. When I plug all the information into the formula, we get $6,489.36, which is what he's paying 4 times a year. In order to find the total amount of the payments, we're going to take that $6,489.36 and multiply it by 40 since there's 40 total payments. So his loan that he took out for $150,000, with his interest, he's paying $259,574.40. If we add our $50,000 down payment, the total amount that he has paid for this house is $309,574.40. Lastly, we're going to find the total amount of interest that was paid. So we're going to subtract $200,000 and we get $109,574.40. James and Ava have $30,000 for a down payment, and their budget can accommodate a monthly mortgage of $1,200. What is the most expensive home that they can buy if they borrow money for 30 years at 7.8% compounded monthly? So we have, in this case, how much of a payment that we have. So we have the value of R. We have that there are going to be 360 payments, and that my interest per period is going to be 0.0065. So we're looking for the A sub n value. We have 1,200 is equal to A sub n times 0.0065 over 1 minus 1.0065 to the negative 360. We can calculate this entire term in our graphing calculator and use the calculator to do the work for us, as you can see on the side. When I divide 1,200 by the value of this fraction, we get that the A sub n value, so the amount of the loan that they could take out, is $166,696.65. Since they have a $30,000 down payment, they could actually afford a home that's worth $196,696.65. In this last example, we're going to construct an amortization schedule for a loan that's $10,000 with interest at 10% being repaid in 5 equal annual payments. So the very first line of my schedule, no payment has been made, no interest has been made, so we just have our unpaid balance of $10,000. The first thing that we need to figure out is how much our 5 equal payments should be. So the amount of my loan is $10,000. We have 5 payments, which are annual, so once a year. So that means that my interest per period is going to be the full 10%. So calculating using my loan amortization formula, we get that each payment should be $2,637.97. Let's look at the first period. So they're going to make a payment of $2,637.97. Well, since we have 10% interest on a $10,000 balance, that means the amount of money that's going towards the interest is going to be $1,000. The remaining balance is going to go towards the principal. So if I made a payment of $2,637.97, 10% of my balance that's left over went towards the interest, that leaves me with $1,637.97 that's going to go towards the principal. So that means that my new unpaid balance is going to be $10,000 minus $1,637.97, which means we're left with a balance of $8,362.03. We do this process all over again. So the payment doesn't change because we're amortizing the loan. We need to figure out how much of that payment is going towards interest. So we take 10% of this $8,362.03. You can see here how I kept repeating the process of finding 10% of the unpaid balance, subtracting the payment minus the interest to get the balance reduction, and then finding the new unpaid balance by subtracting the balance reduction from the previous unpaid balance. We continue until all of our periods have been completed. The last step is to look at what our totals are. So we add up all of the columns. You could see that we paid a total of $13,189.88 on a $10,000 loan. $3,189.88 went towards the interest, and that gave us a balance reduction of $10,000. Now you may notice sometimes that the balance reduction, the last value, might be slightly off from our unpaid balance. That's due to rounding errors. So if you're off by less than 10 cents or so, that's actually pretty normal. When you get your loan amortized at a bank, they don't round any of the decimals. They keep everything in the exact form. So that's why it always works out exactly through either a credit card or a loan company.